let's have a look at the problem with jitter and how we can try and resolve the issue that we have with jitter. So ideally what we're looking for, especially when we're dealing with traffic such as voice and video, we would hopefully have a perfect steady stream of packets arriving. Now that's certainly how they're constructed when we send them. So as the person is talking, if we're dealing with a voice call, for example, so let's focus on that for a moment. If we're dealing with a voice call, as the person's talking, we're taking their voice, we're putting it into packets, we're dividing those packets up as they should be, and we're sending them at this constant, perfect pace. Every packet is the same size, every packet has the same distance between the packets, so there's no gaps. Well, there is gaps, but the gaps are perfectly symmetrical, and they're all 100% as they should be as you're going through. Now, this is ideal, and this will give you absolute perfect quality when it comes to the voice quality, and of course video quality. The problem with jitter is it's going to end up making the call sound a little bit like this, where the packets are in wrong order. So they start coming in A, in the wrong order, but 2, they have these huge gaps in between the packet, and it sounds horrible. And it's not something you can actually have a good conversation with someone if you're experiencing a lot of jitter. How jitter gets created is because of the fact that we have this variance in delay as traffic gets transmitted from point A to point B. So as it's getting transmitted from point A to point B, we've got different buffer delays, we've got possibly different paths, where one voice packet goes one direction, another voice packet goes a different direction, and on those different paths there's different propagation delay, different serialization delays, different buffer delays, etc. And when the packets arrive on the other side, these 3 look like they're pretty good, they're in the right order, everything's looking fine with those 3, but then there's this monstrous gap here. We get another packet, and then we get this other huge gap before we get the next one. And these gaps obviously are going to cause the quality to degrade in a very bad way. So we have to have some way to try and combat this problem. This is done through what's called a de-jitter buffer. The principle is to take these packets as we receive them and put them into another queue, put them into a buffer. The principle is, and although this diagram has all the nice facts and figures for us, think of it this way. If the packets look like they did in the previous slide, where we have this big gap, and then we have this big gap over there, and then we have these 3 packets back to back. If this is how they were received, and I put all of those packets into a buffer, well then I could play them out of here in the correct order, but I could also play them out in the correct spacing. So I play the first 3 out from this buffer. This gap I can then remove because I already have the packet ready in the buffer to be transmitted. I can grab that packet and I can send it in the perfect timing, removing this big space that took place. Then I can take this packet and send that one right in the right time again. While I'm taking these packets and removing their spacing and playing them out, don't forget more packets are arriving and getting put into this buffer. So now we maintain this buffer to make sure that there's always packets in it, so we've always got something to send. And if we've always got something to send, we can always put things in the correct order and play them out at the correct speed. So this is also why the de-jitter buffer is also known as the play out buffer, because it's the speed at which you play out the traffic. Now, as we're receiving these voice frames from our network, they're getting put inside this queue, and we have this normal operation where the queue depth is sitting somewhere in here, and you'll notice that it's never empty. We always want to have something in the buffer, so there's always something to transmit. We ideally are hoping that this buffer is always inside of this area and never gets to full completion. If it gets to the full end, then packets that arrive here have got nowhere to go. So we always want to make sure that this buffer is hovering between the maximum and having something inside of the buffer itself. So this fixed playout rate also depends on what the codec is that we've used. So we want to make sure that if we look at things such as having an underflow, then our queue will empty if the voice frames are arriving too slowly. So then it's a case of, well, we set the packet, well, I don't have anything else to send, so I'll have to wait. Okay, now I have to send another one, it's arrived, but it's happening too slow. We have overflow, which happens if the queue is filling too fast. because then I don't have enough space to keep those packets, and I'm unable to play them out at the same speed. And then, of course, we have the perfect sort of point in the middle where everything is balancing itself out, and that normal operation of the cue depth fluctuating at the perfect pace is what we're looking for. Generally speaking, this de-jitter buffer will usually be around the 30 millisecond region, right? And that's not cast in stone, it's giving you an idea of where it fits. So at about 30 milliseconds is what we're looking at for a de-jitter buffer, or a playout buffer as it's otherwise known.